What's up, 7th grade? Mr. Agnos here. This video is for homework 2-3. And all this topic, we've been talking about proportional relationships, something that you guys already know a lot about, but now we're just adding a lot of new vocabulary. Right? We're specifically talking about them from a mathematical point of view. And one of those new vocabulary words that we've been talking about is the idea of a constant of proportionality. Right, a constant of proportionality. So in this topic, you're specifically looking for the constant of proportionality, but they give you the information in different ways. Sometimes it's a table, sometimes it's a graph, sometimes it's like a pictogram. I think maybe this is what this is called. But the bottom line is, however they give it to you, we need to figure out what is the constant of proportionality. And to find the constant of proportionality, you always do it the same way. Okay, the constant of proportionality is equal to the ratio of y over x. Okay, if we're thinking about it from a purely mathematical point of view. Okay, so if they give you a graph, if they give you a table, we always want to do y over x, and then simplify if necessary to find the constant of proportionality. So let's look at number 1 here. It says the variable y is in a proportional relationship with x. The number of squares represent an x value. So these 3 squares right here are my x's, and the number of ovals represent the corresponding y value. So these are all y's, and it says identify the constant of proportionality. Well, let's just figure out how many y's we have. 1, 2, 3, 4, 5, 6. So y is 6. How many x's do we have? 3. We want the ratio of y over x. So I do 6 ovals over 3 squares. Remember, this is just a division problem, right? 6 divided by 3 is 2. So the constant of proportionality in this case is 2. Well, what does that mean? That means there's 2 ovals for every square. All right, there's 2 ovals for every square, and we can actually see that. I'm gonna delete this here real quick. Again, you can always pause if you need to. If we look at, here's 2 ovals, 1 square. 2 ovals, 1 square. 2 ovals, 1 square. So there's always 2 ovals for 1 square. Go ahead and put 2. Got it. All right, let's take a look at number 5. Number 5, they give us a table. This is similar to what you guys have worked on before. It says, however, does the table show a proportional relationship? So we don't know if this is actually proportional. So the way that you figure it out is you say, okay, well, what is the ratio of y to x? If it is the same thing every single time, then it is proportional. If it's not the same thing, then we have a non-proportional relationship. So here's my first set of information, 35 over 5, right? The y value is 35, the x value is 5. 35 divided by 5 is 7. Let's check the second one, 42 over 6. So I would say 42 is the y value, 6 is the x value, 42 divided by 6 is 7. So notice that I'm getting 7 every time. If I were to get a different number, if I got a 7 here and then a 4 here, that would be a non-proportional relationship. So here I have 49 over 7. That's also equal to 7. And then the last one is 56 over 8. Right, it's always the ratio of y over x. 56 over 8, that is also equal to 7. So, because we got 7 every single time, then we do have a constant of proportionality. Whatever your x value is, multiply it by 7, that gives you the y value. So look at my choices. The table does not show a proportional relationship. That's not true, right? It does show a proportional relationship, and the constant of proportionality is 7. Got it. Again, pause, rewatch if I'm going too fast. All right, the next question I'm going to look at is number 7. All right, number 7 is a graph. So how do we find the constant of proportionality from a graph? Well, we need to locate an x and y coordinate. Excuse me. I'm sorry. This one's actually even a little bit easier. It tells us the variable y has a proportional relationship with x. So we know it's proportional. Now remember from last week, we also know it's proportional because 1, it's a straight line. And 2, it passes through the origin. Right? Any graph that does this, right? There's the origin, and it's a perfectly straight line, right? My line's not straight, but theirs is. Any graph that does these two things is proportional. So how do I find the constant of proportionality? Well, the easiest way to do it is just to go to the, first I'm going to click the pop-out window, is I don't like how that popped up, is to go to 1 on your graph, go up and over, right? So here's my y value of 43, and here's my x value of 1. So that's 43 over 1, which is equal to 43. So if we know the graph is proportional, like we do in this case, then this is the easiest way. The constant of proportionality is going to be 43. And, you know, you can check another point if you like. I can go to 2 here, go up and over. The y value is 86. The x value is 2. 86 divided by 2 is 43. But again, since we know it's proportional, then the easiest way is just to go start at 1, go up, go over, and you'll find your constant of proportionality. Got it. All right, let's take a look at number 10. The number of pizzas is in a proportional relationship to the weight of the shredded cheese toppings. When shredded, a 50-pound block of cheese is enough to make 162.5 large pizzas. Okay, so that's some information we're probably going to need here, so I'm going to underline that. A 50-pound block of cheese is enough to make 162.5 large pizzas. We know that there is a proportional relationship because they tell us. Find the constant of proportionality. All right, and it says the constant of proportionality is blank pizzas per pound of cheese. This is important. So how many pizzas per 1 pound of cheese? So the way we find this is, let's go ahead and take our number of pizzas. Let's put it on top. All right, we have 162.5. And let's put our cheese on the bottom. We have 50 pounds. All right, 162.5 divided by 50. Right, if I do that, that will tell me how many per 1 pound of cheese. So I have no idea. So I'm going to use a calculator. I have 162.5 pizzas divided by 50 pounds of cheese. That means that I can make 3.25 pizzas. Right? Now you can put a 1 underneath any number, right? So it's just per 1 pound of cheese. So the constant of proportionality is 3.25, right? So if I said, okay, you have 12 pounds of cheese, how many pizzas can you make? Well, you would take 12, you would multiply it by 3.25. I could make 39 pizzas, right, with 12 pounds of cheese. So my constant of proportionality in this case is 3.25. Got it. All right, I think I got time for one more. Let's look at number 14. The graph shows the number of calories burned while running. Estimate the constant of proportionality of calories burned to time spent running. And then what does the point 25 to 25 mean? All right, the constant of proportionality is about what? Okay, so the key here is we want to estimate. So if I just look at 10 here, okay, I go up and I go over. It's not quite to 100. Okay, so remember, time, this is my y value over here. So I have 90 something over 10. I have 90 something, I'll just put a 5 for right now, over 10, right? 95 calories in 10 minutes. And again, I'm just estimating this 95. It could be 98, could be 96, who knows? It's close to 100, right? If I divide 95 by 10, I get 9.5. So that would be my constant of proportionality, right? It would mean every 1 minute, I'm burning 9.5 calories. So let's see if 9.5 is close to any of my choices. I have a 9 and I have an 11. So which one is it? Well, we know it has to be the 9 because we're at less than 100 here, right? In order for it to be closer to the 11, we would have to be above the 100, right? I would have to be like somewhere up here. That would make it closer to 11. So in this case, it's approximately 9 calories per minute. We got it. And what does the point 25 to 25 represent? Well, remember the x-axis is measuring time, and the y-axis is measuring calories. So if I have the point 25 to 25, 25 here, remember this is the x coordinate, this is the y. So this 25 right here means minutes. So in 25 minutes, I burn 225 calories. So 25 calories burned in 225 minutes? Nope. 225 calories burned in 1 minute? Nope. 225 calories burned in 25 minutes. Yes. Okay, I know I go, ooh, I'm kind of blurry. I'm blurry. Oh, it focused. Okay, I know I go kind of fast in these videos. That's because it only gives me 15 minutes and I'm almost at the end here. So if you need to pause, rewind, rewatch, you can do that. All right, in fact, I highly encourage it. As always, this is not enough to get you through the whole assignment, to give you a full understanding. This is enough to get you started, right? To give you a little push, but you got to be asking questions in class. All right, guys, keep up the hard work, and I'll see you soon.